I'd like to present to you the GeoSoftware Petrel link for 2024.3. So first, I'd like to show you the data that's I have here in Petrel that I'd like to quickly and easily transfer back to HampsonRussell. I've got 4 different horizons, several seismic volumes, including substacks. I have also got 5 different wells. And here we can see that while the wells exist, they're not yet, they don't have a time depth relationship, and so they're not yet tying with the seismic. So the first thing to check to make sure is that the plugin is actually installed. So here we can see the GeoSoftware plugin is installed and it is the current release. The next thing to check is that it is running. So you go ahead and open that, and it does say the server is running and it's running locally. All right, so let's bring up our empty HampsonRussell project here. So there's nothing in it, so no seismic, no horizons. So let's go ahead and first import our seismic. So we're going to do so using the Petrel link here. It's going to ask us to connect up to the project. And then we've got 2 options here. We can either copy the seismic and it'll create a seg-y in the project. And that's helpful if you're wanting to close Petrel and free up the license. Or you can choose to have a live link. So let me go ahead and import the live link. That means that the seismic is pointing directly to the existing seismic volume. It instantaneously shows up in Petrel. And you can examine it, and it acts just like seismic. It's very responsive. Let me go ahead and show you that you can also as well import through the copy option, and you can do so by zones. So I can select zones or set up the zones. So right now I've already selected and created these zones around all the wells. This will enable you to deal with large volumes. So I'm going to select all of those zones that I'd created around the wells. I can also decimate it, and it'll go ahead and go through each of these volumes. So it's imported all of these substacks. And as you can see, based on the fold, they're just around where these wells will be located. So let's go ahead and import our wells next. So we'll import the wells via the plugin. It's going to default to importing all of those wells with known log types. And so if you have log types that are kind of unusual, you might want to go through and map them, which is possible. So now we can see that I can navigate to these well positions. They've already mapped to our seismic. And then the next step here would be to import our horizons. So I want to do that quickly and easily. Import all the horizons, those 4 horizons that are available. Here they are. And this will enable me to do some tying of the wells to the horizons. So if we go ahead and examine these horizons in the in the horizon database display here, I'm going to go ahead and change their coloring. So green, yellow, red. Okay. And save those. And so now on the seismic, they'll be colored with their name. And I'd also like to display my top. So when I imported all of those wells, they came in, of course, with their tops as well. So I'd like to display the green and the red top here. Oh, and let me likewise specify their appearance. Okay, So this particular well, let's go to well number 4. So here we see well number 4. Let's look at the full seismic at well number 4. And we can see that this well is not yet tied. So upon import, by default, the P-wave log is integrated, so there is an initial time depth, but it at minimum will require a bulk shift. So what we'll do next is to bulk shift this well and tie it. So let's go ahead and examine this well. So this is well number 4. So it has 4 logs here and a number of different tops. And so we'd like to tie it to our full stack live. It's going to extract the composite trace for a neighborhood of 1 trace around the central trace. Okay. And so right now my green top here is, I'm not displaying my horizons here, so let's display the horizons here. Okay, so I'd like to tie this green, this vent with the green event. So I've got my synthetic created from this wavelet, which will extract a better one in just a bit. And then I've got my seismic trace extracted from the well path and repeated several times. So I'm going to apply this bulk shift. And let's, and then these yellow bars indicate how this correlation is being computed currently. So it's a correlation right now of 0.34 or 34% approximately. So let's see if we can improve that. So let's first extract a statistical wavelet. We're going to extract just along the inline where this well exists for speed. And then let's do a window where that is relevant to where the trace exists. So down to say 2200, 12, that should be sufficient. Okay. All right, so we have this nice looking wavelet here. Goes to zeros at the tails. So let's go back into the well scene. So it's been applied already. I'm already looking at, let's change the correlation window here. So go down to 2300 and say from okay. So let's see if we can edit, make some tweaks to this tie now. So again, make sure the green top is going to stay still. I'll take this event here and tie it here, and then at the top it looks like tie this with this. As we go along, you'll see that we have some QCs here. So I've got the equivalent sonic that's the velocity changes that would have occurred based on these stretches, and I've got my drift curve to make sure I'm staying within a limit here, and then my corrected two-way time. So these are very gentle stretches, and then also an interval velocity change. Let's go ahead and apply those. I've got a much better correlation now, up over 50%. It suggests a small shift I'll go ahead and apply that 1 millisecond shift. I could also examine, say, if phase rotation might benefit. So I could go here and say scan, and it recommends a minus 25-degree phase rotation, and that would get me up to a 51% correlation. I think I'll stick with the zero phase wavelet for now until I have other evidence. So you could as well, I just extracted a statistical wavelet, but you could of course use the wells themselves, and you have these other options: a full wavelet, constant phase, and Roy White. But for now I'll stick with that wavelet. And then let's say OK in order to apply this new time depth relationship. Let's go back to our seismic and make sure well number 4, yes, it seems to align now with our horizons and tops. So let's shift this, or let's export this back to Petrel. So to do so, I'd go to my processes. It's easy to find them if I just start typing in Petrel, and I'm gonna I can export all of these or import all of these types of data to and from Petrel. So in this case, I'm going to export wells to Petrel. I've just tied well number 4, so that's the well I'm going to send back out. I only need to send the depth time log. Okay, it's one-way time. All right, and then let's go ahead and say OK, and it says that it's transported that well into Petrel. So let us check out. Okay, and now we see it's already showing up here. This is well number 4, and it's showing as a 2-way time. And if we examine well number 4, we can see that this GeoSoftware plugin folder has shown up, and here is the one log that's been exported. It's the depth time that's now active. And I could verify and say turn on my tops now for well 4. And we can then see that these tops align with this top right here and this top below with these surfaces now, and so the well is tied. So thank you very much for listening to this or viewing this demo.